Okay, to start out this chapter, like I said, we're doing some review of our exponent rules from Algebra 1, so just running through those real quickly at the top. An exponent, first of all, an exponent only belongs to the base that it is attached to, okay? The base of the exponent is only the thing that's attached to the exponent. So there's a big difference between 2x squared and 2x squared, right? So in this first example, what is the base of the exponent? Just the x, not the 2, right? Only the thing next to the exponent. And in this one, the 2 and the x are being squared because they're in the parentheses. The squared is on the parentheses, so the squared is on everything inside of it. So this would be like 2 squared and x squared, 4x squared, okay? Second point here, terms must be alike, right? Terms that have exponents must be alike in order to add and subtract. And this is familiar, right? If you want to add 2x squared plus 5x squared, you can only do that because they're both x squared, right? We get to say it's 7x squared. But that's not true if they're not both x squared. So this is a familiar rule. But terms with exponents that want to divide or multiply must simply have matching bases. They don't have to have matching exponents, right? To multiply terms that have exponents, they just have to have the same base. And if they have the same base, then we can apply these exponent rules to what the exponents do in multiplying and dividing. So first of all, the coefficients, the numbers in front of the x or in front of the variables and exponents, those just multiply or divide normally, okay? But whenever you're multiplying, the exponents add. So this is a good example here. 2x to the a times 3x to the b. The 2 times the 3 makes the 6. And then the x times the x, okay, those go together, but the exponents add. A plus b would add. And when you're dividing, you would subtract those exponents. So we have 8x to the a over 2x to the b. So 8 over 2 is 4, of course. And then x over x, that turns into 1x, but the exponents subtract a minus b. Okay, so your exponent rules there. When an exponent is raised to a power, then the exponents multiply. So here we have a good example. 2x to the a, that's all being raised to the power of b. So what gets the power of b? The 2 and the x to the a. The 2 gets the power of b. There it is, 2 to the b. Okay, and then the x to the a gets also raised to the b, and those multiply. A times b, the two exponents multiply. Okay, a negative exponent gives the inverse of its base, right? So 2x to the negative third ends up as 2 over x to the third. And honestly, that's the rule, but here's kind of how I think about these. I think of it as like everything, the exponent, a negative exponent, takes it and its base to the other side. Okay, so it goes to the bottom. It takes itself and its base to the bottom. If it was already on the bottom, then it would take it and its base to the top to turn positive. Okay, so that's how the x to the third lands on the bottom. The 2 stays put because it's not part of the base. It's not in parentheses. And then the last little point here, any base raised to the power of 0 is equal to 1. So 4 times 3xyz to the power of 0, all of that comes down to simply 1. Notice x, y, and z are gone. Please do not write x to the first, y to the first, z to the first. They're gone. They all turn into 1. Okay? Anything to the power of 0 is just 1. So 4 times 1 is 4. So that's a crash course through your exponent rules. Let's do 4 little examples, and then I'll turn you loose on your assignment for the day. Okay? So this first example, 2x cubed times y to the negative third times 2x to the negative first y cubed. We're just multiplying these. So your coefficients, the 2's, they multiply like normal. 2 times 2 is 4. Your x's will multiply together. That's an x cubed times an x to the negative 1. When we're multiplying and they have the same base, what's the exponent rule? You add them. So 3 plus negative 1 is 2x squared. Okay, so x squared. And then the y's. The y's, y to the negative 3 and y to the third. What's negative 3 plus 3? 0. Okay, and of course anything to the power of 0 is 1. So I don't cross it out and just leave it crossed out. I always write a 1 over it so that I can remind myself, if everything else were gone, if all of that was gone, would the answer be 0 or would it be 1? It would be 1, right? If the entire expression is being canceled out, the answer is still 1. So, and for that reason, the math purists really don't use the phrase cancel out. They use the phrase reduce, because reduce has a meaning of 1. Cancel out kind of has a meaning of 0. So, okay, number 2. 2h cubed, and I think yours might have a typo here. This is supposed to be k to the 4th on the top right of number 2. I think yours might say L on accident, so just change that to k. We want that to be k to the 4th. So, all right, here we go. We got a fraction, so we're applying our subtraction rule. When the terms match and we're dividing, we are subtracting their exponents. So 2 over 3, we can't really do anything with 2 over 3, the coefficients, but certainly the j's and the k's. So let's talk about the k's first. Now, technically, the rule is subtraction, and you should think of it as k as a subtraction. 4 minus 1 equals 3, so that should leave you with a k to the 3rd. Okay, so you should think of it like that. And I've seen SAT questions that are written specifically to see if you know that rule. But when I'm simply simplifying an expression, I like to think of it instead as a cancellation. There are 4 k's on top multiplying together. So k times k times k times k over one of them on the bottom, a k on the bottom. And so one of them on top is canceling with one on the bottom, leaving how many left over? 3. Where? On top or bottom? Top. Okay, so this is how I think of it whenever I'm approaching a problem. I see the 4th on the top, the k on the bottom, and I say, oh, okay, that k is going to cancel out one of these 4, leaving 3 behind. Okay. So you can do the subtraction, or you can do the cancellation like I just showed in red. Please don't do both. These are different strategies to accomplish the same thing. Don't mix them up and do both. Okay. Either do the subtraction or do the cancellation. If you really love the subtraction, that's fine. You can just talk to me afterwards about some of the nuances that you have to remember with that. Okay. And then the j to the negative 3rd. Ugh. I don't like that. I'm going to take that negative exponent and its base, and I'm going to send it to the bottom. So here's what I've got. 2h to the 3rd over, or k to the 3rd also, over 3 times j that was on the bottom, and then j to the 3rd is joining it on the bottom. And now I can combine those j's on the bottom by multiplying them together on bottom. So that means we get j to the what? To the 4th. 3j to the 4th. Okay. All right. Why don't you try number 3 and number 4 on your own? I'll put a few hints up here to get you started. These problems are so big you could approach them in a variety of ways. So just because my first step is different from your first step, that's okay. If you know what you're doing, trust your gut. But if you're stumped, you can look up here for a first step. So there are a few first steps if you need it, and I'll pause the video for now. So on number 3, after I got done with my first step, that's what I got. Yours might look different if you took a different route. That's fine. And my last step for number 3. Goes like that. There's that. You can see that hint again for number 4 if you need to see that hint. highlighted in red. Remember, when you raise an exponent to another exponent, you're multiplying those exponents. And my next step after that, if you need to see it, you can look up here. So when I'm multiplying, I see I'm going to add those together. Again, you don't have to do it that way. You could take a different route if you wanted to, but I saw that. It's pretty easy to add those up. And then as my last step, you could have done this in the previous step, and you'll still get to the same spot. Take these negative exponents and their base, and only their base. Notice the 2 on the bottom is not moving. The negative exponent and its base switches sides to turn positive. And then I'll go ahead and subtract or cancel those 3's, the 3 and the 8, those last 2 exponents. So you could think of it as cancellation. Those 3 x's take out 3 of the 5, or 3 of the 8, leaving 5 behind. So what is the answer here? Is it 2x to the 5th? Is that my answer? Is this a good answer? 2x to the 5th, like that? No. What did I forget? There is always an understood 1 up there. If the top totally disappears, there is still an understood 1 up there to hold its place. It will never just totally disappear. So 1 over 2x to the 5th.